Okay, so this is 2019 past paper. We're starting from question 3. I hope you all have this paper. Question 3A. 1. Complete a square of the quadratic function f of x is equal to 3 plus 2x minus x squared. And then you should sketch indicating all the properties. To complete the square, we first rearrange this, put it in the right order, and then make sure that the coefficient of x squared is 1 by factoring out the negative, and so it affects the other numbers negatively. Then you go to the half of 2, because 2 is the coefficient of x, and add that half, square it, subtract, square it, and then get this x, get this sign, and get that number inside the power, square this, and then you can now square this number, so 1, and then minus 3. And then we have negative x minus 1 squared minus 4. When you expand, the negative remains there, and it makes that positive. So we are done completing the square. The only thing remaining now is to sketch. So for you to sketch, we need to know the turning point. The turning point here is you get the x minus 1, equate it to 0, and so for x, that becomes the x value. And then the other value, which is for y, you get this number here, the way it is. To know whether it is maximum or minimum, you look at your a there. A is negative 1, which is less than 0, so it is maximum. If a was greater than 0, minimum. Then now you look for the x-intercept. X-intercepts, you have x minus 1 squared plus 4 equal to 0, because we know that x is 0 on the y-axis. So from there, then you get negative x minus 1 squared is equal to negative 4. Divide by negative, divide by negative 1. You get x minus 1 squared is equal to positive 4. Get the square root, get the square root. X minus 1 is equal to plus or minus 2, implying that x is equal to 1 plus or minus 2, which entails that x is 3, or x is negative 1. Then the y-intercept, you go to the function and substitute 0 for x, you get 3. So the y-intercept is 0, 3. This is because we know that x is 0 on the y-axis. So that from there, you now have, what else is remaining? Okay, everything is there. So I can sketch. The turning point is 1, 4. 1, 4. There. And so the graph will go like that. You know this is -1. That's +3. So everything is well indicated. This is 3. So that's a full graph with easy full working. Nothing has been left out. So you obtain how many marks here? Marks not indicated. Okay. So that's the procedure. Every time you are told to complete a square and sketch. Sometimes they'll just say complete a square and state the maximum or minimum turning point. So just complete and state. So any questions here? Any questions? Okay. We got the question. How did we get the -1 inside? When you say inside, you mean here. We get this x, get this minus, and get that 1. So you have the -1 inside. Get that 1 with its sign. So you have another -1 inside. And then -3. Because if you expand this, it will give you these terms from here up to here. These first 3 terms. That's the meaning of that. Okay. So A2.
So
Yes.
for the polynomials, how do you know where it's maximum or minimum?
That's now further differential calculus. So we'll do that. Is that fine? So polynomials will use further differential calculus to know where it is maximum or minimum. So A2 x squared plus 2 minus k. Hello?
Can you please repeat? I didn't.
Hello?
Can you kindly repeat on the last part? I got disconnected.
The last part here, we are solving for the intercept, where you just equate this to 0. And then you get the values of x. Then you go to the function again, substitute 0 for x, and then you get the y-intercept. Then you put the points together on the graph, and that's what you call the sketch. So find the range of values of k for which the quadratic equation this is equal to 0. Now, has complex roots. For you to determine the nature of roots, what do we use? We use the discriminant. Okay, the discriminant comes from the quadratic equation. We say that if we have ax squared plus bx plus c is equal to 0, x is going to be negative b plus or minus the root of b squared minus 4ac over 2a. Now we call this inside part the discriminant and denoted by d this. And we say that if d is equal to 0, what is going to be x? So if d is equal to 0, x is going to be negative b over 2a. So what we say? We only get what? If d is equal to 0, then the roots are equal and real, because there will be no complex here, and it will be just one root, meaning that the roots are equal. Okay, 1, 2. If d is greater than 0, okay, if d is positive, then you're going to have something like x is equal to negative b plus or minus, should I say plus or minus e over 2a. So I'm saying e because if I take a positive number inside the square root, it will give me some number. If I take 4, I'll get 2. So there will be plus or minus 2. If I take 16, I'll get 4. If I take 7, I'll get root 7. So plus or minus root 7. So that we get two values. That is, x is negative b plus e over 2a, or x is negative b minus e over 2a. So there will be 2, then the roots are, let me just use the same language here. The roots are real and distinct. So they are real and different. If d is less than 0, if inside there we get a negative number, x is equal to negative b plus or minus negative 2 over 2a. That's a negative number inside. So automatically we obtain, if d is less than 0, then the roots are complex. For complex, there's nothing like real, different, distinct, what? When you say complex, automatically they will be different. So if d is greater or equal to 0, you expect to have real roots. If it's strictly greater, they will be distinct. If it is equal, the roots also be equal. So now, question A. What do we have? We have our A is equal to 1. Our B is 2 minus k. And our C is 1 minus 2k. Okay? For this to have complex roots, what values of k should we have? So we'll say the discriminant then must be this b squared minus 4ac. We require that it becomes less than 0 so that we obtain the complex roots. So we'll substitute. So this implies that 2 minus k squared minus 4, a is 1, c is 1 minus 2k. This must be less than 0. So we get 4 minus 4k. I'm expanding now on the left, plus k squared plus k squared minus 4 plus 8k is less than 0. Okay. So the key thing is you should always know that this is what leads us to a quadratic formula. Okay, and in the quadratic formula, when you start it, you notice that if your d is 0, then you have equal real roots. If your d is positive, then you have real and different roots. They will be distinct. If d is less than 0, you have a negative number inside the square root, then you get complex roots. So that this one now becomes a quadratic. K squared plus 4k, then the 4, this 4 and that 4 we get 0, and so this becomes less than 0. Then you factor out k, there will be k plus 4 less than 0. So you get the critical points, the critical values, that is k is 0, so k plus 4 is 0. This gives k is equal to negative 4. Then from there, you form a table. You don't conclude using this. You form a table. That is negative 4 here, 0 there. Pick a number in between these guys. Okay. Say negative 2. Pick a number after 0. You can pick 1. Before negative 4, you can pick negative 5. And then you have k. You have k plus 4. And then you have the product plus 4. So this forms the table. And you know what we are looking for. We are looking for the sign of the product. So don't forget the purpose of the table. So I'm looking for the sign of the product. So when k is negative 5, we'll be getting a negative. So whenever we have a number less than 4, we'll be getting negatives. When k is negative 5, again we have another negative. When these two are, when you multiply these two, you get a positive number. If k is negative, you get a negative. Then negative 2 plus 4, you get a positive number. The product, negative. 1, positive, positive, positive. You want where it is less than 0. So the solution set is going to be negative 4, 0. You don't include any because you're just looking for where it is strictly less than 0. So this becomes the set of values for k, for which the quadratic that is given there is going to give the negative roots. So whenever you face any question on discriminant, any question about the nature of the roots, you always use the discriminant, and that's how you use it. So this is a general way of revising the past papers. So we have tackled everything about the discriminant in one question. So that when you find it in another question, it will just be a task where you just exercise and see if you can still get the answer. We go to B. Solve each of the following equations. 1. The root of 2x plus 1 is equal to the root of x plus 1. So what do you do? You square. So you square this side, you square this side, you're going to have 2x plus 1 is equal to so x plus 2 root x plus 1. Okay, so you can decide to leave this alone here and take everything else to the left, so that we have 2x minus x plus 1 minus 1 is equal to 2 root x. So here we just remain with x is equal to 2 root x, and then square. So we have x squared is equal to 4x, so that we get x squared minus 4x is equal to 0. So x minus 4 is 0. So x is 0, or x is equal to 4. If you try, in most cases, these we test. So you take a 0 there, you take a 0 there, it will be satisfied. If you take a 4, we have 8 plus 1, which is 9. The square root of 9 is 3. Then root 4 is 2 plus 1 is 3. So these are the solutions. So if you are dealing with equal sign, you just square. That's how you do radicals. Another one. So we have the second one, the modulus of 2x minus 3 is equal to 3x minus 5. Modulus, by definition, away from the question, we say if you have this, it will be equal to x, provided that this guy is greater or equal to 0. It will be negative x if x is less than 0. The meaning here is you want to have a positive number without using the modulus. Because you know, if you take a negative 2 in the modulus, automatically it will come out as 2. Okay, now you're trying to avoid using the modulus, but still get the required result. So what do? If you take 2, you allow it to be 2. It's fine, the modulus has already worked. But if you take a negative number, the best way not to use the modulus is by multiplying that number with a negative. It will still be 2. That's the meaning of this. That if you have a negative number inside the modulus, if you don't want to apply the modulus directly, you just multiply that number by a negative, it will become positive. So you're looking for ways of making a number positive. Okay? So now you can go back and say, okay, what I have as my question is 2x minus 3 is equal to 3x minus 5, provided that my 2x minus 3 is greater or equal to 0. It is negative 3x minus 5, provided that 2x minus 3 is less than 0. Then you pick them one at a time. The first piece becomes 2x minus 3, which is equal to 3x minus 5. Okay, you can work out the inside ones where you take 3 to the other side and divide by 2. Okay, maybe we do that so that the first one here will take time. Then the other papers will be a bit fast because we would have laid the ground already. This would be x greater or equal to 3 over 2 and 5 minus 3x for x less than 3 over 2. So here I've just multiplied, I've expanded these brackets here, and so I've said with a positive 5. So now the first piece becomes 2x minus 3 is equal to 3x minus 5. So if I bring 5 the other side and 2x the other side, that would be 5 minus 3 is equal to 3x minus 2x. I'm just avoiding the negative. So this will give us 2 is equal to x. Okay. The second piece, 2x minus 3 is equal to 5 minus 3x. Now this time around we bring the 3x, and take the 3 the other side. Again, avoiding the negatives. So this becomes 5x is equal to 8, and so x is equal to 8 over 5. So if you take there, this must work. If you take 2 there, you have 4 minus 1, which is 1. And there you have 6 minus 1, which is 1. If you take 8 over 5, excuse me, let's see what we get. We'll have 8 over 5 minus 3. So the same as 16 over 5 minus 3. So 5 down. So I have 16 minus 15. Yes, this is 1 over 5. We take 8 over 5 on the right. You have 8 over 5 minus 5. So this is 24 over 5 minus 5. So 5 down, 24 minus 25. That is negative 1 over 5. Now negative 1 over 5 is not the same as positive 1 over 5. So what do we do? You discard the other value and remain with the other. So you say, therefore, x is equal to 2 is the required solution. because the other one is giving the modulus to be negative, which is not true.
Sir. Sir,
Huh?
do you mind solving question 2B, the quiz that we had?
Okay. Do I have the paper near?
I have the question.
Okay, so you can just send it to my WhatsApp
Okay.
as we log out, because we only have how many minutes? 4 minutes remaining. So let's log out and log back immediately. Then we'll start with that question. Please, let's log out
Sir.
and log back immediately.
Sir,
Yes.
before we solve that question, may you please explain where you've broken it down into part 1 and part 2?
So the part 1, I was just equating this to that. The part 2, this to this. Following the definition from here and here.
So
Then,
following the definition, we always have to use the two parts. We don't just pick one.
no, you use the two parts. That's a full modulus definition. If you only pick one part, then what about the other part?
Okay.
Wisdom, we haven't solved the one you sent in the group. Okay, let's log out.